So let's look at the verifier annotation. So what is the verifier annotation? So remember we've been looking at the callable annotation, which I have explained that this is the API for your D app. That means that this is how the outside world or any front end will be able to interact with your D app to perform any designated operation. So also the verifier annotation, it's used to verify outgoing transactions for an account that is scripted with a D app. So it must always return a boolean, meaning true or false. So the value of that boolean, if it's true, it will determine if a transaction should be recorded on a blockchain. If it's false, the transaction should not be allowed by such an account. Okay, so we have a very simple verifier function, which is powered by the verifier annotation. So the verifier annotation exposes some details about the transaction, which should be the transaction amount and so on. Okay, and it also holds the transaction type and so we are going to use the match structure in RIDE in order to check for certain transaction and set rules which should serve as guards for this D app. So what we have here is that any transaction that matches the set script transaction type, we want to check if the account making the outgoing transaction is the D app account. And this D app account is a variable, which is a local variable which I have created here, and this value here is the public key of the D app account, which is this wallet that is going to hold our DApp when we deploy it on the blockchain. Okay, so I just call it D app account public key, and it's of type base58. All right, so how I could, so in the Waves IDE, online IDE, you quickly just click on the drop down and you click on the copy of the public key. So you're clicking on it, you see copied, and I just quickly pasted it here as the value of this variable. Okay, so that's it's being held here, and you would notice it's way over on the top. This is also because in RIDE we tend to want all local variables, local functions to be before any callable or any verifier. So it's good standard practice that all your local variables, because RIDE is going to enforce it. So make sure that all your local variables and your local functions are way on the top. Okay. So this is what I said in my verifier. So any transaction matching set script transaction, only the DApp account can perform such a transaction. If any other account try to, the blockchain will reject it. And by the blockchain, I mean Waves blockchain. It's going to reject it. So for invoke script transaction, I just want to perform a simple script verifier. Just verify that the account calling the transaction has the proper credentials in terms of whether it's really the owner calling from that account, calling from that wallet. So you check the owner public key, you check the proof, you also check the address. Alright, if everything matches, which is going to be checked by the SIG verify. The SIG verify function is short for signature verify. So you're going to verify the signature to make sure it's authentic and there is no funny business being made. Then every other type of transaction, I just want it to be false. So the only two transactions that goes out from this account is set script transaction and invoke script transaction. That's the only two transactions that can be performed. Okay, so our D app seems to be in good order. So a brief recap. Remember, this is a directive. These are the directives for the RIDE compiler, and this is a variable that holds our D app public key, which we use in our verifier annotation. This is our first callable function, which is our callable annotation, which exposes the I, which is the invoke script transaction data, which would hold the payment and the address and all that. So these are deposits. Is going to help our DApp users to deposit funds, which are waves, to this particular account. Also have the withdraw. Alright, we have the withdraw callable function, which allows the user to withdraw only the amount he or she has deposited, not more, not less. So you can withdraw less, but you can withdraw above, and you can only withdraw the ones you have deposited. Alright, so our D app is in good shape. The next step is to deploy it. Okay, so to do that, we would need to fund the wallet DR. Now I've already funded the wallet DR, but I really need to show you guys how to do that also. So you can see I have 19 waves, and these waves, as you can remember, we are on testnet. Okay, we're on testnet, right? That's where we are right here. So there is, I'll head over to waveexplorer.com. Okay. Alright, it's going to load up in a bit. Yep. Alright, then I'll switch the network to testnet, for that's where we are. So if you could see, when I switch to testnet, there is this faucet link, and the faucet allows you to fund that account with a maximum of 10 waves. Alright, so you fund that account with 10 waves. I just quickly paste the address there, and I confirm that I'm human. Definitely I am. Then I'll click on the request 10 waves button, and if everything goes well, I would have funded our supposed DApp account with 10 more waves. So we should be having 29 waves, and you can see that over here. Alright, so that's how that's one of the ways that Wave makes DApp development a breeze. Alright, so with that you could do your testing and all. So with that done, I'm just quickly going to come to the console over here, right, and type in deploy. So the deploy function allows you to deploy a smart contract onto an address, but make sure that the address you want to deploy the smart contract to is being checked on this side. Right, so if you can see this is checked, make sure this is checked, not another account is there. So make sure that's the account that is checked and it's all showing over here, and also make sure the account have the funds for the deployment. So I'll click enter. Yep, our smart contract has been deployed, our DApp has been deployed, and Wave makes it easy for you to quickly check if that transaction really went through, which I think it did. By clicking the link to transaction in Wave Explorer link, you could see the transaction that just happened. So when I click on it, it's going to take me to Wave Explorer on the testnet, and it's going to show me that particular transaction. Alright, so this is the transaction ID, and I see this is my script. It's already been compiled to base64. This is the fee. This is the sender, which is this. So let's confirm that this is really sender. So let's look at this address over here, and it's still the same with this address over here. So we have successfully deployed our script, and you could just decompile it right in Wave Explorer to see if that was done successfully, and it was. Alright, so that is our introduction to Ride, and I hope you really learned something and you would ride on Waves blockchain using Ride.